Hey guys, NJ here. So today we're looking at a new printer from the Chinese company Creality. Now a while back I reviewed the Ender 3, which I still think is an absolutely fantastic machine, a great entry into 3D printing and something you can learn with. You can print a lot of parts for it. There's just heaps of support for that printer. And it's very well loved for it. Now for the extra couple of $100 above that, you've got this new guy, the CR-10S Pro, and in terms of the specs, certainly on paper it's boasting some nice features. Now some of those features include, obviously you've got the heated bed as you do with the Ender 3, but this one goes up to I think 110 degrees, which is plenty hot enough to deal with most types of filament. You have dual Z screws, which is again fantastic, so you get a really nice even Z layer height when you're printing. I think that's a really nice thing. All the electronics are housed in the base here, so there's nothing kind of out, there's no power supply mounted up on the side, it's all housed internally. We have a touchscreen down here, which is a nice interface for the printer itself. We have a single ribbon cable connecting to the gantry up the top here. Again, fantastic, just keeps things super tidy. That one ribbon cable connects to it, and then everything else that comes off of that is powered and run off of that one connection up top. And then we have a proper branded Meanwell 24 volt power supply, again all housed internally. We have Trinamic stepper drivers, which super quiet on the print without a doubt. Very little printer noise itself from those, so again really good, really smooth. You can see from the way it moves and the way it sounds, it's definitely a step above what I was used to, certainly with something like the Ender 3. And in terms of assembly, it's really very simple, certainly in terms of what you get out of the box. I'll show you a couple of pictures of what this thing looks like when you get it. Really there's just kind of 4 screws to put this whole top section on. The whole top section is bolted together and just slots on 4 bolts and the whole thing's built, so great from that point of view. Obviously with the Ender, the whole thing has to be built in kit form. You've got a bigger bed as well, and sometimes it's a tricky thing to describe how big a printer actually is across the camera, but hopefully you can see the Ender in view. You can see it really does kind of dwarf it. I think we've got a 320 by 310 bed here, which is a pretty huge bed, and then 400mm in terms of height, so you've got lots of room, nice big print volume, which is obviously fabulous. So what other features do we have here? As I said, lots of aluminium all the way around. We have dual gears for the extruder, which is great, and we have an auto bed leveling sensor and a filament run out sensor as well. So yeah, on paper this all looked great. Now I have seen some videos. When I said yes to reviewing this, I have already went and had a look at some of the videos that are out there already and seen what people's general experiences were, and certainly from what I've seen the end of the spectrum where they've had a really quite fantastic experience with this printer, and with a lot of these Chinese companies that can vary quite a bit. I had a great experience with the Ender. I didn't really have to do too much to it mechanically, it all just kind of worked. It was a great experience out the box, but again I know people at the other end of the scale that got one with a pretty warped bed, and things didn't go together too well, and there's always a spectrum to this stuff. And I will say, in the case of our friend the CR-10S Pro here, I did in fact have that bad end of the spectrum. I definitely had a lot of issues to deal with. Now I have this thing working and printing fantastically, let me say that off the bat, okay, but it required some work. And I'm hoping some of the things that I talk about today are going to be, there's going to be people who've maybe had some of these problems or are having some of these problems, and hopefully I'll cover some of those things and how to solve them. In terms of the out of the box experience, as I said, 4 bolts to get the whole thing together. It comes with a reasonably comprehensive colour manual showing you how to put it together and the steps to go through to get the auto bed leveling sensor leveled and sorted out. and it came with the latest firmware as of doing this, which I think was, oh god, I can't remember, 1607. I'll make sure I put this information in the description, so please check it, but it is the latest one as of the publishing of this video. And I guess we can probably start there in saying that's the first problem I ran into. When you get the SD card that comes supplied with it, there is the standard Creality test dog on there, and I plugged it into the printer and immediately saw absolutely nothing, and I thought, well, why have they sent me a blank SD card? So I plugged it into the computer, and of course the folders are there with the test dog print, the G code for that. And I thought, well, why is the printer not seeing this? So I had to do a little bit of deep digging, and it turns out the latest version of this firmware is meant to have fixed that, but clearly it didn't for me. So unless the file is actually in the root and not inside a folder, the printer won't see it. So I dragged it into the root of the file, put it back into the SD card slot, and it didn't see it again. I then did some more digging and found out that it doesn't like long file names, so I had to reduce the file name, renamed it to something under 8 characters, and then I saw the file to print it. So these are things that need fixing in the firmware and should be sorted straight out of the door, and Creality know about this problem, so really this is something that they should have fixed by now. I mean, there isn't a newer firmware update, but it's something that needs fixing pronto, because that's not a great first time experience for someone who's just got this printer out the box. But there you go, you've got the information about that. Other bugs with the firmware include problems with it not retaining settings after you have leveled the sensor and set the Z offset. I found doing that, and also doing the 16-point bed calibration, that it didn't retain the settings. As soon as you power cycled, it was all lost and you'd have to do it again. Obviously that's extremely frustrating and needs fixing. Again, they claimed it was fixed in the latest version, but mine said it was the latest version and it didn't work. I was going to reflash all the firmware on here. This printer does have the board that's in here does have a bootloader on it. So you don't have to faff around installing a bootloader, which we all know is a real pig, especially if you've put one on the Ender 3 to update the firmware on that, which I did. So updating it, you can do it with a hex file simply via Cura if you're running the Cura slicer very easily, or you can use the Arduino software. That's a fairly simple process, but let me stop you there. Don't do that. Thankfully, Tiny Machines came to the rescue in such a massive way I can't begin to tell you. They have fixed pretty much all of the big issues, and some have, you know, added some small features in there that have really made this printer an experience that it should be out of the box. So my first piece of advice to you, if you've got this printer, is to go and get and I'll link this in the description, go and get the Tiny Machines firmware installed on here pronto, because that just solves a lot of the problems. The SD card thing's not really an issue for me because I use Octoprint, but using Octoprint with the stock firmware, I found that it wasn't reporting temperatures to Octoprint. Again, Tiny Machines firmware fixed it. So yeah, just go and do that first. Those guys are brilliant, and their own version of the firmware is fantastic. On that page, you'll also have some G-code settings that you can put into your slicer, which are obviously super useful, as well as a bunch of things like, I'm not sure if that's coming out on the camera or not, but I've actually got a red display. They give you the option of updating the screen with red, green, blue, violet. You can choose, you know, if you want to match it and you're particularly OCD about colours, you can do so. I should probably point out that there is a separate piece of firmware for the actual screen to the main board. So once you've updated the main board, the next thing to do is update the screen, and you have to take off the, I don't know, 12 or so screws on the base. Very simply, take that off and you'll see on the inside the screen has an SD card slot on the side of it, and the instructions for flashing that simple process are on that Tiny Machines page. They'll show you how to do that. Very simple. You're simply dragging a folder onto the root of a FAT32 formatted, like an 8 gig SD card. You drag that folder on there, you pop it in, you power it, and it will go through a sequence which I'll show you here. And then when that's done, take the SD card, turn it off, take the SD card out, and you're all up to date on the Tiny Machines firmware. So really go and do that first. The second thing I should say is the Creality videos for setting the bed leveling and also the instruction manuals are outright wrong. Do not follow them. They're just wrong. Don't do it. again, Tiny Machines to the rescue. They have a video showing you exactly how to level that properly. So I suggest you follow that, and they will show you exactly what you need to do to get this all leveled and to start getting that to work. Now, let me talk about the sensor. The sensor that comes with this as stock is a capacitive sensor, and it comes set too high. That's the biggest problem that you'll find straight away. The sensor is set too high up. It needs lowering. The lower you can get that capacitive sensor, the more accurately it will work for you and the more consistent your first layers will be as to where you want them. So that's not to say the capacitor sensor can't work. It's my least favorite of the sensors. It's sensitive to both the temperature of the room and humidity, and that causes some variation. Even with it nice and close to the base, I just found occasionally it wasn't quite as the results weren't repeatable that often, and I put it very much down to that capacitive sensor. So what I've actually done is switch out to an inductive sensor. Those are super cheap. I mean, you know, $5 or $6 for a cheap Chinese inductive sensor. I can link the one that I've used in the description if you want to fit that. You will need to cut and solder the old connector, or fit a new connector to it to connect to the board up inside the aluminium shroud that's mounted to the main gantry. I'll show you some pictures of that. It's a pretty straightforward mod. I think it's Nexi has done a video on step-by-step video on how to do that. Great video. So if you want to actually swap that sensor over, it's super cheap to do. You can go and do that, but you can get great results with the standard capacitive sensor. I just felt like it wasn't super repeatable, and that's why I've switched. If you want the best of the best, you can't go wrong with a BL Touch. It's not sensitive to anything. It just sees a surface, it will touch it and say that's how far you are from it. Dead easy. So that's the way to do that. But as I said, with the Tiny Machines firmware in, all of the settings were being properly retained. The Z offset was being properly retained, and everything worked fine. Now, let's get on to my biggest bugbear. Certainly with the information that's out there, that I think this needs talking about, which is mechanically setting up the leveling of the gantry of the x-axis, and the way that Creality have suggested you do it, and the way I think it's been suggested in other videos as well, because these two Z screws aren't linked in any way. There is a modification on Thingiverse which allows you to add pulleys and a belt, which essentially times these two Z screws together, which can be done fairly cheaply. I think it's, again, probably 10 to 15 bucks worth of parts, and you can do that. But I don't think it solves the core issue which I had, which was that mechanically it wasn't set up straight. Okay, so what do I mean by mechanically straight? Now this is the important bit. Now it's pretty obvious that because these move independently, the two Z screws that is, you will have to, no matter how mechanically straight this is, still adjust one side to the other to get everything level at some point or another. Now, what I mean by mechanically straight is the actual bracing of this x-axis against the plates. So against this plate here and against this plate here. Now, the actual holes that the screws go through to brace against this plate are large enough to where you could loosen them and actually move one Z screw up, one Z screw down, and then if you were to tighten them, let's say this was done in the assembly process and it wasn't quite straight, you've actually got a bracing at an angle that is not 90 degrees. And with that slight angle in there, and it might not be something you'll pick up by eye, you'll then have one side that naturally wants to force down. If you get this side to one point, it might still want to force down the other side. So then using the independent twists of each side to force it straight might do that if you then engage the stepper motors. But the problem is, the minute they disengage, the mechanical pressure of that not being straight will force that side down, and that's exactly the problem that I had with this one. Every time, and I've actually seen this in a few other videos, instructional videos, where I've seen them go through the official process for leveling the gantry. That same thing happened. They put the shim under one side and leveled it, moved across and leveled this side, and the minute they pulled the shim away, I actually saw the physical movement of one side go down. And that's because, as I said, it just mechanically wasn't correctly braced against these plates at 90 degrees. Once they're at 90 degrees, there's still going to be enough play in the mechanics that you could twist the Z screws to make it go off either side slightly. So you'll still need to do that system of one at a time to get them both completely level. The point is, once you have it level, you then don't have a mechanical pressure once the motors are disabled for it to go off. It will stay where you leave it. And that's the important thing to understand here. So the first thing we're going to need to do to actually properly level this is to disable the steppers, and we're going to need to take this up and off, just slightly off of the top here. So you're going to need to remove this top bar. So 4 screws to take this top section off. And then what we're going to do is we are going to loosen 2 sets of screws here. We're going to loosen both of these are accessible from the other side. You'll see a hole in the back plate where you can access one of the screws here on the back, and then the other screw here which is accessible from this side from the back again, and that will allow this to float against that back plate here, so that whole section side can move. We're going to do a similar thing on this side. We're going to need to loosen 1 screw here, which is connected to a wheel on the other side, and then sadly the other screw we need to loosen, there's 2 here that are blocked by this aluminium section here, this aluminium post. They're blocked by it, so we're going to need to lift this up and off the top so that we can loosen the one that is closest to the stepper driver, and we're going to leave the middle one tight. We're going to leave that as it is, and that is so that it acts as a pivot for us. Now, once you've loosened those 2 screws there and those 2 screws there, we're going to put the whole thing back on. Okay, we're going to put these back on, and we're going to lower these down. We're going to take our 2 printed blocks here, and I'll link these in the description. And we're going to place these so that we have those in place, and we're going to make sure that the stepper motors are disabled, and then we're going to lower this down until we have both sides touching and we have the same amount of tension under each block. So that feels quite stiff. This one feels a little bit loose. So I'm just going to lower that Z screw a little bit till that feels the same, which is about there. And then what you're going to do, we now know we've got this square. This is perfectly square. So what we're going to do is we're going to go back to the other side, and we're going to tighten up these 2 screws, and that fixes the angle of this side to be nice and square. Over here, we've already got 1 screw tightened, which was acting as a pivot or a seesaw for that to be adjusted. That's already tight. What we're going to do is adjust the other one we can get to now, which is here, which is this wheel. And when that's back up nice and tight, we have 2, although they're close together, we have 2 tight screws which will hold that angle that we now know is good. We're going to disable the stepper drivers, and then we're going to very carefully slide that up so that we can access the innermost screw or the outermost screw here. We can now get to that, tighten that up, and then bring the whole thing back down, and this time when you lower it down, everything should be perfectly square. So it's a pain to have to do that, but if yours is out, do this, and then once I did that, mine is, once it's square like this, every time it's power cycled, occasionally I'll come back and check it, it doesn't matter, it's perfectly square every time, which means I don't have to worry about when the stepper drivers disable after a print's finished, or when the power's cycled, it's always staying where it was left, which is nice and level. And I've had this sitting here now for about a month while I've been playing with it, and in that time that's never gone out. So that is how to do that. I strongly suggest you do that and get it mechanically sound, and then you really don't have to worry about the leveling of that gantry again. You certainly don't have to do this, you know, this crap of holding one side and twisting another. You don't have to do that again. It will just be good. You know, maybe check it once a month, it'll be fine. Okay, so we've talked about the firmware and upgrading that. We've talked about the sensor and why I've gone to an inductive sensor. Cheap to do, but you know, as I said, that's your choice. You see how your results are before you worry about doing things like that. And we've talked about leveling the gantry and why I think it's important to do this mechanically. Now, the other thing that I think is worth talking about is the actual main housing. Now, I did upgrade this. There is on Thingiverse, which I will link again, a bullseye style cooler here. Now, it's hard to talk about this without touching on the fans, but the fan that comes with it, which I think is a 4020 pusher fan that runs at 24 volts. All the fans, everything's running at 24 volts on this. I found that fan to be a little bit noisy and a little bit rattly, and when you're paying the extra for a printer at this level, that's I guess it's kind of mid-spec, I'd expect some slightly better quality fans. They're sleeve bearings, they're a little bit noisy and rattly, and yeah, I didn't like that. I wanted to go with my preferred fan size, which was the 5051. I think that most other, a lot of other printers use. They're quieter, there's lots more options for them, and if you step down to 12 volts, I mean, you can get 24 volts actually. You don't need to step down to 12 volts for the case of the parts blower. You can, I think that is a 24 volt actually, but you still have lots of options for proper part cooling fans with decent bearings in them that are quiet, because that's an important thing for me. So this bullseye print that I printed in PETG on this before actually swapping everything over, there's a couple of reasons why I prefer this. So this is the stock shroud that you get on the CR-10S Pro, and to be honest with you, there's a few reasons why I didn't like it. Again, the fan that was in there, I just thought it was super noisy and running at 100%, and just it's kind of brute forcing a load of air into this cavity, with the original setup, the sensor's also in there as well. Obviously you don't need to cool the sensor, but I just found I wanted that whole thing to be more refined and quieter. By going with this bullseye kind of design, which has a much more refined airflow, really nicely designed, again linked in Thingiverse, I'll make sure the link's there for you to check out. It meant I could run with a lower CFM, kind of quieter fan that has the airflow going more directly over the hot end fins. So that was much more benefit. It's focusing the airflow over the cooling, so you don't have heat creep or any kind of other problems you'll get. You can run with a quieter fan. It's all bonuses really. So that's why I moved to this this particular type of cooler. As I said, with this bullseye, I was able to run with the part cooling fan that I wanted, and it had a dual fang, so you didn't have any weirdness in, with just air going in one direction over your print as you do with the stock one. It blows the air in a nice direction and blows it straight down onto the part, much more evenly distributed, which gives you better prints and gives you less kind of strange, you can get some strange warping effects, and sometimes when things lift off the bed, that can be due to the airflow going off to one side and just cooling one side of the print more than the other. It's just better to have the airflow to be more focused and evenly distributed. So that's why I went for that particular thing. If you do go for this, one other thing I should mention, when you upgrade your firmware, you will need to run with a different offset, which you do in configuration H. You'll be able to move down, and there's actually a little description for how to set the distance, the offset of the sensor to the nozzle, because this sits further away than the stock mount does. If you don't make that modification, the first thing it will do is try and sense off the edge of the bed, and obviously all that will do will drive your nozzle straight into the bed. Ask me how I know. In terms of the extruder, it's now all aluminium. It has dual gearing on the extruder, which is great, so it's got a good grip on the filament. And I've found it to work very well with the TPUs the TPU filament that I use. I don't use the super soft stuff, but I use stuff that's flexible enough for mounts for GoPros, for my multi-rotors and things like that, and I've had really fantastic results. The Capricorn tube, much higher accuracy, works really well, good quality couplings, all metal hot end. It just all works so much better in terms of the handling of the more flexible filaments, and with the other filaments as well. I found I've probably needed about half the amount of retraction that I've needed on, for instance, the Ender 3. So it's definitely printing very well for me for a Bowden tube setup. But obviously there is a limit with flexible filament. The more flexible it is, the more it doesn't really suit printing, or the more it suits printing with something like a direct drive. They have done a good job of making sure that as the filament X's those dual gears, where it then enters into the aluminium block that goes off to the Bowden tube, that does actually snug up quite close to the gears. That's definitely a big plus, and certainly a modification that you have to make on the Ender if you want it to print any kind of flexible filament, which I have done, and that did work on the Ender, but at least you don't have to do it on this one. One other thing I should say mechanically that was worth checking as well is make sure, because this isn't really touched on in the manual, that you adjust the runners, the wheels in the runners, and one of those wheels, for instance on the edge here you've got two wheels. This one on the inside has a hex which you adjust with one of the included bolts, and it's an offset center, so basically the wheel can move further in or out, creating pressure against the two running slots. So you want to make sure that they're free as possible, but with no play. Make sure there's no play in there, but as free as possible. If you jam them up too tight, you're giving your stepper motors too much work to do, and you can end up getting things, certainly on the Z-axis, you can end up getting things like layer shifting. Now, in terms of the actual printing, it's taken all this time just to get to the printing. But the printing itself really is fantastic. I've had some amazing results from the things I've printed across a broad spectrum of filaments, and they've all adhered well to the Build-Tac surface that comes included. I haven't felt the need to move to a glass bed. PETG has stuck great. PLA Plus has stuck great. TPU has stuck great. I haven't tried ABS because I have this in my office. I don't really want to be anywhere near this if it was printing in ABS. It might suit you if you've got a big open area or you've got ventilation, but for me it's just not something that I will ever be testing. But I have heard that there have been good results. This heated bed will go up to about 110. So yeah, you can look into that. Of course, there is a glass bed available if you want to do that. Quick note, if you do decide to go with a glass bed, make sure that glass isn't too thick, otherwise if you switch to an inductive sensor it's going to struggle. Capacitive sensor, yeah, they're okay, it'll work. But again, BL Touch, that's the way to go, isn't it? So yeah, here's one of the little models I printed in this silk PLA. Now, it's a little tricky to show you on camera, I'll try and show you close up, but incredible detail, absolutely amazing. Can I get that to focus? Yeah, kind of. Absolutely, you can barely tell, it almost looks like a mold. You can barely tell the Z layer separation on this. Really high detail, fantastic. And I think I printed that at about 60 millimeters per second. Just came out so well, incredible. And that was at a 0.2. It looks like a 0.1, but it wasn't. Really exceptionally good results. I also did my benchmark, although everyone likes using the Benchy. I did print a Benchy with great results, but is my to print this little Pikachu, and I'll show you some close-up shots of that in picture form. But this guy came out looking like glass, and that was, as I said, PETG, pretty fast print, no stringing. It just worked wonderfully with almost stock settings on Cura. One of the things I would suggest that you change in Cura is to reduce the jerk settings, because if you have the jerk settings at stock, which are pretty high, I think when they're at 20, I halved that, I went down to 10, because you are in danger of coming into layer shifting, and that is literally because my theory is really it's got something more likely to do with the fact that it's such a huge bed. There's a lot of mass on there for this thing to move around. If you try and move that too fast, you're going to run into layer shifting issues. So if you do, check your belt tensions. These belts were a little too tight, especially on the Y, so I did loosen them a little bit so that it felt nice and free, but again, no play. Once I did that, I ended up getting things. I did still have 1 or 2 layer shifts actually after checking the mechanics were good and doing everything that I thought would really affect it, like print jerk and acceleration, by bringing those down to within a more reasonable figure. The one thing that I did that did cure it was to look at the stepper driver voltages, and on the Y I did just notch them up a tiny bit on the Y, and that sorted it. Then ever since, I've done probably 30 or 40 prints since then, and I've had absolutely no problem at all. So I don't know, I think at the factory it seemed like maybe that wasn't quite tweaked up to where it needed to be. Be very careful doing that, guys. The main thing to do is keep an eye on your motor temperature. If you notch that up a little bit, make sure your motor's not getting too hot. Mine, you should be able to hold it and it feel, you know, warm, maybe a little warmer than warm, to the point where you're like, you shouldn't be touching it and it's burning you. Then you've got some real problems. You've gone way too far. I think there are some videos on YouTube that show you how to do that, but they require the tiniest of touch if you do want to increase the voltage slightly to the Y stepper. Okay, so the last thing I want to talk about, and I've left this last because it really doesn't bother some people, is the noise of this printer. So as I think I mentioned earlier, this has trinamic stepper drivers in it, and the actual printing noise is almost nothing. It really is great. and I can tell from the way it moves, everything is just, it's definitely a step above something like the Ender 3. Very quiet in that regard. The problem is, if you've ever gone through the process of trying to quieten down your printer, you'll know that you end up chasing your tail because something else becomes the new loud, and it is absolutely blaringly obvious that the loudest thing on this printer is the fan noise. Again, one of the reasons why I changed out the hot end fan and the part cooling fan. The fans they've provided, as I said, are cheap sleeve bearing fans, and I think for the price you're paying you really should be including much better quality fans. It's certainly when it comes to the part cooling fan, because on the sleeve bearing fan that's included, it's actually rattling. The fan itself is rattling because you've got this thing moving from side to side. The actual shaft is moving in and out on that sleeve bearing and rattling, which is obviously a horrible noise. If this is, again, some of this just might not matter for some of you. That's absolutely fine. You might have this printing in, you know, in another room or outside, you know, in your where you keep your car or wherever. But it's in my office, and it really bothers me that there was just so much fan noise coming from this. This whole unit, this whole printer has quite a few fans in. So let's just go through what I did with those. So again, I've talked about the part cooling fan. I've talked about the hot end fan that I changed. I used a buck converter, a step down converter, which took the 24 volt supply down to 12 volts. So that I had way more options for 40mm fans. Went for a super silent fan. I'll link that in the description. I used that fan in 3 places on this printer because it's nice and quiet and has a decent amount of airflow. One was on the hot end with a step down. The other one was the exhaust fan. I switched out for one of these and used a step down for that. And a pack of 5 step downs is nothing. It's like $10. So I used it for that. And the third place I used one of these fans was with a printable mod. Was to cool the main board down and the heat sinks that are sitting on top of the drivers. So they decided to use the same part cooling fan running at 100%, which is noisy as hell, across the board. I mean, it's used for part cooling. You don't need that kind of airflow to cool a board down. That's just ridiculous. But yeah, they chose to do that. So I used one of these with a mount that I found on Thingiverse that someone had made up, and that works absolutely fine. So again, no noise from cooling the board, very little noise here from the hot end fan, and very little noise from the exhaust fan pulling any hot air given from the power supply out the back of the case. So that's how I took care of those and brought the noise down on those. I think the one that offended me the most in terms of its noise was the, and this one's on Meanwell and not on Creality, is the power supply. Because if you look at the power supply, most power supplies, especially like the Ender, they have a larger 90mm fan on the side, which is running constantly at a low RPM, and it will only ramp up if it notices the temperature of the power supply getting hotter. That's the way to do it, absolutely. Because this is all quite shallow, the power supply they've chosen to put in here has a 40mm by 20mm, so a deep 40mm fan on the end. Not the worst, necessarily the worst thing in the world. The worst thing about it is the way in which they've decided to program the cooling for that, which is the power supply saying, well, I'm too hot now, so I need cooling. And then that fan running to 100%, which is noisy as hell, until it deems it's past the point where it's like, you're cool enough now, I'm going to turn off. It then gets to that hot point again, comes on 100%. So you've got this constant cycle of the power supply going 100% cooling fan and off. What it really needed to do was have a program which, like the other ones, had a consistent like 40%, which had been way more quieter and probably kept it at a stable temperature, and then only ramp up if it needed it. So that was really frustrating. Either way, despite being a 24 volt power supply, it does actually supply 12 volts to that fan, and the fan's actually very easy to slide out. And I replaced it with a 12 volt Noctua, which is obviously, it's Noctua, it doesn't make any noise, so I don't even hear that anymore, even though it's still running that 100% nothing algorithm, which is just ridiculous. So that's the way to solve that. I will say this just as a disclaimer: any of these modifications you do at your own risk. I know what I'm doing with electronics and microelectronics because I studied it and I know how to do it, and I'm comfortable with the soldering iron. I've been playing with soldering on the circuit boards for at least 20 years, so I'm very comfortable doing stuff like that. If you go anywhere near your power supply with a soldering iron, that's on you, and my honest advice is live with it, don't touch it. But I'm just giving you the information for how I went about changing mine. Power supplies are very dangerous things, be fully aware of that. So I think I've kind of covered all the things that I want to right now. I'm sure you guys have a bunch of questions. If you want to get in the comments, please engage with me. If you've got similar experience, if there's other stuff that you've got problems with, I've probably experienced, I've had all the problems with this that I've gone through and sorted. In terms of recommending this printer, look, here's what I think. I think I got unlucky in terms of having to do a lot of messing around with it. Really, this printer's advertised as 4 bolts and away you go. In its current form, you're at least going to have to sort out the firmware with the Tiny Machines firmware until Creality bring out something equal or better to sort out the problems that I've talked about today. And again, follow the Tiny Machines bed leveling method. Do not follow the one by Creality, because it will go wrong and it will frustrate you. If you want me to do a separate video on any of these things, like the bed leveling, talking about in more depth about any of the fan modifications, if you want to see more on what I've done on the inside of this, please let me know. I will quite happily answer any questions that are put in the comments. So yeah, without digressing, do I recommend it? Look, when it comes to the printing, this prints fantastically. This really does print fantastically, and everything I've printed on this has just come out wonderfully. But it's been a journey to get here, and I shouldn't have had to do half the things that I did to get to that point. If you're happy to do the things that I did, then by all means go for it. But the printing part of it, which is the important bit, it prints great. It definitely prints great, and it works with all the filaments that I tested, the flexibles, PETG, all the PLAs. You know, most of the stuff I've checked on here has just been wonderful. And now with this sensor I've chucked in here, it's been getting consistent, repeatable results, which is what you want. So yeah, this is the main printer for me now and getting the most use. If you want to help me out, please follow my link to shop at GearBest, whether you're buying this or whether you're buying something else. I'll get a little kickback and it will keep them happy and keep them sending me stuff to try out. So, and hopefully to review and to give you lots of useful information. So thank you for bearing with me. I know this was a long video, but I hope you've learned something, and I hope I've answered some and helped some of you that have maybe already got the CR-10S Pro, and we've learned a little bit about it. So thanks for sticking around. Hope you enjoyed that. I'll see you guys in the next one.